Hi, this is Javin, a production chemical engineer by profession, going to continue our today's topic, Rotary Ball. Now, a rotary valve, also called rotary motion valve, is a type of valve in which the rotation of passage and passage in a transfer plug regulate the flow, liquid or gas, through the attached pipe. The common stopcock is simple as from the rotary valve. The rotary valve have been applied to numerous applications, including the changing the pitch of the brass instrument, the controlling the string and exhaust port of the steam engine, most notably in the Crossel steam engine, the periodically reversing the flow of air and fuel across the open hearth furnace, loading sample of chromatography column, the certain type, the two-stroke, the four-stroke engine, most of hydraulic, automotive power, the steering control valve. Now used in industries. Rotary valve for industrial manufacturing. They are often used in bulk material handling, dust collection or pneumatic conveying system depending on the application. The valve is used to regulate the flow of product material by maintaining a consistent flow rate suited to the process. The controlling the flow of material help to prevent issues such as jamming, material leakage and damage to the valve itself. Typical application are feeding the white hopper for the feeding mill that can be clogged by the product. The valve are part of the material exchange process and work in a metering feeding application, function as rotary airlock or provide combination airlock and metering function. A rotary valve is the pharmaceutical, chemical and food industries is used to dose and feed solid bulk product within the process. The valve are also commonly used in construction, plastic recycling, agriculture, forestry or whether material need to be safety and efficient conveyed from one point to another. An air-knock type rotary valve receive and dispense material from the two chambers with different pressure level. They are seal airflow between the valve inlet and outlet to maintain a consistent pressure differential which promote efficient material flow. The valve pressurized chamber prevent the foreign material from the infiltrating the housing and keep conveyed material from escaping the system. The rotary valve, also known as rotary airlock, rotary feeder, they are pneumatic valve that handle and meter the flow of granular bulk or powder. The material is fed into valve via hopper or other inlet handled through the valve rotor and then deposit onto conveyor system in discrete packet. All the minimal pressure loss. They are most often used the air conveyor system to minimize the loss of pressure across the valve, but rotary valve are also used to meter material at the control feed rate. They work almost exclusively in air system and function as airlock, expansion, flame barrier and process isolator among other tasks. They can move dry to slightly sticky products and find many applications in chemical and food, pharmaceutical, plastic and other manufacturing market. Rotary valve are composed of four main components: an outlet housing, a rotor bearing and seal and a drive. The housing is the rightmost component in and provide inlet outlet bolt as well as protective pathway for material through the valve. The rotor is held in place. The rotor bearing, the material is sealed with the valve inner housing via bearing shaft seal. The drive mechanical, typically electric motor attached to the rotor shaft from the outside to control the rotation speed and direction of the rotor. The product is fed into the valve, captured into equal pocket between rotor vane and the dispense in even amount of outlet. These rotor vanes have tight clearance with the housing and prevent pressure losses, material losses through the valve, ensuring the pressure differential remain intact. Now rotary valve type. There are many variations on the rotor valve, all suited for the unique application. Each component can be configured to meet different needs at the below section. will be briefly explain how certain part the different provide different kind of rotary valve. Housing style. Housing can come either inner or offset arrangement depending upon the need. The inline housing configures the inlet directly above the outlet, which is more efficient and generally practiced and practical in most applications. Offset housing internationally skew the inlet from the outlet prevent product sharing and overfilling, but they are less efficient and more nice in their application. There are also low light design and one of the arrangement all meant to provide the best valve functionally to specific job. Rotary style. The rotor design is highly specific to the application at hand and come in many types. There are closed end rotor, the open end rotor, metering rotor, staggered pocket rotor, reduced volume rotor, helical rotor, adjustable rotor, flex tip rotor, radius pocket rotor, and many more. Other of type, each is unique material and needed. They are typically no less than 8 rotor packet and therefore 8 when in a rotor, but increasing the rotor amount will be increasing sealing capacity at the cost of filling efficiency. Replaceable when they are also popular as rotor tend to wear with time, but they generally not used in large rotary valve. Now drive style. The most of rotary valve are powered by a synchronous electric motor connect to a reduction gearbox and chain setup allowed at the precise speed control and regulation. Additional speed monitoring equipment and variable speed control can be added. This is drive making the rotary valve useful as rotary automation valve. There are also hydraulic motor that can power the larger rotary valve, but they do not use the gearbox and the reserve for the more specific use. Now specification plus selection criteria. Since the devices are dependent on application, there is a lot of specify when choosing the right valve for the job. This section will detail some of the important specifications to understand the considerable rotary valve, but note that this is list the not fully comprehensive. Always consult your designer and supplier about specification as they will have the most relevant information and resources. The application plus performance requirement. Understand that you are using the rotary valve for and what it must accomplish. This means calculating the desired throughput rate, defining material characteristic, density, flow, coefficient, estimating efficiency, and other important metrics. They are valve and value. They are dependent all aspects of valve. So be prepared to alter this specification as needed. Operating speed. Rotor speed will affect throughput rate, the valve wear, valve size, and more. Understanding the right speed at which to run your rotary valve will help with efficiency and maintenance. It is generally said that the rotor should not exceed 40 meters per minute, but again this is dependent on rotor type, material characteristic, and more. Rated temperature and pressure. If the rotary valve will be used in a pressure or vacuum system, unsure, it is rated for this condition. Also be sure to define the working temperature of the surrounding and of the material so that no part of the valve is overtaxed. There is significant thermal effect between the rotor and the housing, especially full speed, as the rotor generally expands at a different rate, which can cause unwanted lacking or maintenance. Unsure, they are chosen rotary valve will not exhibit this effect in your application and can handle and heat. Connection type. How will you valve connect to your larger system and how will it feed and discharge? These are all important specifications as different feeding and discharge equipment can be used to differential successes. There are hopper, feeder, blower, simple piping and other equipment, so figure out which one will be used to your project. Specifying this aspect will also allow you to find a rotary valve that will come with the correct connection characteristic of your greater application such as welding, sport, throughout halls, etc. Material of constructions. Now finally, determine the possible chemical and physical effect can occur between your product and wall and choose a material that can stand up this stress. For example, stainless steel rotor blade will resist rust from the wet media while bronze rotor tip will not wear down as easily as other kind. Choose a wall material that will keep your pressure, vacuum, integrity if needed and make sure that material is rated for the estimated lifespan of your project. Now application. Rotary valves are used in almost pneumatic conveyor system, but they also find uses many other applications. This section display how indensable these valves are and how they can still find new uses. Some of notable applications: rotary valve that are food and chemical processing application, pharmaceutical manufacturing application, abrasive product, conveyance, metering, plastic manufacturing, frequently cleaned, a biotic application, pneumatic conveyance, and more. The ball valve is the most common example of valve family valve that include rotary valve, piston valve, and other valve that use selective positioning of inner core with one or more through hole or cavity to direct flow from the one or more inlet port to the one or more outlet port. Rotary airlock valve. They are also called rotary feeder, rotary valve, or just rotary airlock, used to both pressure style, the vacuum style pneumatic conveying system. This valve serves as a lock to prevent air loss while simultaneously the performing vital material handling function in industries. A rotary valve is used to regulate the flow of product, usually reduce the flow rate to level more the suitable to the process being undertaken. Often application do so between area where the gas pressure are different on the different side of the valve. The control product, the flow rate to the required rate, fixed or variable, maintain a gas pressure differential between the inlet and outlet, act as an explosion barrier, act as a flame barrier, act as a process isolator barrier, as well as satisfying any one of the combinations of this need. The valve also have to overcome any adverse characteristic the product being handled to complete. The matter further, the product characteristic can be altered. The duty conditions, which are not always stable, now withstanding the about 60% plus of the application can readily satisfy from the standard component, and if necessary the inclusion of the components addition feature, the remainder tend to require specialist input in order to ensure satisfactory performance and service life. All cases technically competent supplier will examine the duty carefully to ensure that the right until the offered and to ensure that any special consideration are identified and provision made. Now is rotary valve limitations. The designing system incorporating rotary valve and consider the choice of unit, especially when acting under pressure differential. It is important to recognize a rotary valve does not create product flow. It can only pass such product that can fall into it and out of under gravity. All rotary valve leak air or gas when the system is operating, regardless or whether there is pressure differential or not, and this can affect the product flow and system performance, especially where the gas pressure below the valve is greater. The faster the rotor speed, the lower and more erratic and filling efficiency, the greater the pressure differential across the rotor, and the less predictable and less stable the filling efficiency. This factor means the performance of rotary valve is affected by design and performance of the system, and vice versa. The selection of valve speed and size is not precise since they are selected taking into account the various factors that may negatively affect valve performance from the theoretical maximum. The basic performance requirement. This identify the size of unit and consider throughput rate, product density, flow characteristic, any factor that may influence this such valve, throat size, opposing air, gas leakage. There are various factors that affect choice of valve, size, speed, which collectively assess to give expecting filling efficiency because of the varieties of the product flow and system condition. The performance, it is normal to run valve speed that allow time to mitigate some of the factor by the nature and final speed. Therefore, valve size selected is based on calculation, empirical data and mean judgment based on experience, knowledge of the product being handled. The key factor is rotor speed based on calculation. The supported empirical data, it is normally expected the rotor tip speed 40 meter per minute is about the maximum. Thereafter, increasing speed result decreases throughput. This is based on the reasonably free-flowing product having accelerate from the standstill under gravity. Immediately at the valve inlet, the valve running the flooded condition, they may lower the product has low bulk density or there is significant pressure differential giving rise to airflow opposing product flow. Equally, maybe higher the valve is fed under cascade flow conditioning such as is achieved the screw feeder, belt feeder, whether notwithstanding this great care need to be taken operating valve the maximum as filling efficiency will be affected. The various performance can result the erratic and less predictable throughput result, especially the smaller valve size theory. It is therefore possible to run a valve 150 mm diameter rotor the 85 rpm to achieve a tip speed 40 meter per minute, whereas 1000 mm diameter rotor will have limit only 12.7 rpm because of the influence, especially throat size. It is unlike the reliable result could be achieved within the smaller size at the higher speed. Therefore, it is normal practice to select a valve size they give rotor speed below 25 rpm or valve with rotor diameter up to 300 mm. Thereafter, it becomes progressively safer to run closer to 40 minutes per minute tip speed. Now, common addition to rotary valve include positive overload protection, say a pin, priority, torque limiting device, non-rotation, detection, the speed monitor, safety switch on easy clean valve, variable speed control, pressure regulator, and flow meter, and air purge seal, rotor pocket purging equipment. A recent development has been introduction to rotary contact deflection, such as RotaSafe unit, which provide instantly safe detection the moment there is contact between the rotor housing, automatic setting of power to drive motor. This provides significant benefit to the end user to protect the valve from the internal damage, eliminate the contamination in the product from the metal sealing, to prevent startup valve, resemble incorrectly, to detect the bearing failure, protect the autonomous safety system certification, any internal damage to the critical working, the surface immediately render the valve unsafe air leakage and performance as mentioned above. All rotary valve leak air even there is no pressure differential as even the product entering the product displays air into the inlet area. This is significant increases when the operating under a pressure differential due to losses past the operating clearance and carry out the pocket at higher pressure decompressing into inlet. The total such losses are normally referred leakage and given a single quantity value. There are many factors that affect the rate of leakage and ratio of the eliminate make up the total. All are affected by the system conditioning prevailing at any given time. Detailed analysis and understanding the leakage rate is a subject is one right to another occasions. Okay guys, this is up to rotary valve in a very brief manner. I hope you get sufficient knowledge of watching this my video. I hope you get sufficient knowledge and utilize it in your field. Thank you very much.